Now we are discussing Claisen rearrangement. This is very similar to the Cope rearrangement. To understand this Claisen rearrangement, you carefully watch this substrate, this starting material. This is a die. In Cope rearrangement, we use die. Only change is here is a carbon, and instead of carbon, I just added oxygen. So, what is difference between the substrate of Cope and Claisen rearrangement? Here, instead of having both carbons, I am using here oxygen. So, if you look in general, this is nothing but the ether. So, we are using ether for the Claisen rearrangement. Doing the same thing. Now you have to select one carbon and oxygen. Call it as 1, 1, 2, 3 means 3 carbons away from the terminal. So this is the numbering given to the molecule. Now see, this sigma bond which is in between carbon and oxygen is moving here in between 1 and 2. And the bond between 2 and 3 is moving in between 3 and 3. And the bond between 2 and 3 is moving in between oxygen and carbon. So if I show all these bonds with the help of dotted line, I get here cyclic transition state. So this is again cyclic transition state, and we are performing this reaction in presence of heat. So again, Claisen rearrangement is a thermal reaction. And by breaking all these bonds and making bond here, you get here this another compound. This is nothing but the ketone here in this case. So this is a Claisen rearrangement which is quite similar to the Cope rearrangement. Now I'm taking here one more example. In this case, I'm taking here a benzene ring where the oxygen is attached, and here this portion means portion from 1, 2, 3 is a allyl group. And this is again ether, that's why the ether name is given. So which ether here? It is allyl. Allyl means 1, 2, 3, this portion, and the phenyl means benzene ring attached to the oxygen. So this is allyl phenyl ether is taken. Here one double bond here, and another double bond is considered of benzene ring. This is not the double bond like this. This is a double bond of benzene ring which I have considered. Now the moment of bond is very similar. Oxygen, I have to select oxygen and carbon here. 1, 2, 3. 1, 2, 3. So 3 carbon away, actually 3 position away from the terminal. So this carbon and this oxygen. So shift this bond here, this bond in between 3 and 3, and this bond between here 1 and 2. While doing so, the aromaticity of this benzene ring is disturbed. So remaining 2 pi bonds of the benzene ring remain as it is because we are not moving, we are not shifting them anywhere. So we have to draw these 2 pi bonds here in the benzene ring, and this is nothing but the cyclic state for this ether. Now if I show the complete moment of bonds, I get here a double bond which is shifted here. This 3-3 bond means this is 3 and this is 3. This bond is formed, and I have taken pi bond from the benzene ring. So aromaticity is totally disturbed. That bond I move here outside the ring in between oxygen and carbon. So I got here actually ketone. But here I can regenerate that benzene ring once again by just shifting this bond because hydrogen is there. So this hydrogen, there are 5 hydrogens on this benzene ring. I have shown 1 hydrogen where this carbon is attached. So I can shift this bond here in between or within a ring. This bond is converted as a pi bond, and this hydrogen is moving to the oxygen, and that hydrogen is joined to the oxygen by using this pi bond. If I do that, I get here hydroxyl group, and this 3rd pi bond of the benzene ring is regenerated. That means aromatic center is regenerated. That is quite favorable. In fact, the conversion of this ketone to the aromatic ring is very fast because this is very favorable. Aromaticity is gained during this reaction, and we get here ortho allyl, As I mentioned, these three groups are the three carbon, or this moiety of this compound is allele, which is now attached at the ortho position. So this is called orthoallele phenol. This is called orthoallele phenol. So in this way we discuss the Claisen rearrangement. Thank you.